our climate. The ice ages have come and gone. And what's surprising is that there's a strong pattern that explains why ice ages happen when they do. This is called the Milankovitch Cycle. Named after Milutin Milankovitch, his theory explains how the Earth's climate changes over hundreds of thousands of years. His theory is based on two key ideas. First, the Earth's climate is strongly affected by how much sunlight the northern latitudes receive during the summer. Second, this amount of sunlight varies based on changes in the Earth's orbit and rotation. Why are the northern latitudes so important? It's because of ice. When sunlight hits the ground, most of the energy is absorbed as heat. But if the ground is covered in ice, most of the light reflects away because ice is white. This creates a positive feedback loop. Ice forms when it's cold, but ice also reflects light, making it colder, which forms more ice. So ice is really important for climate. The northern and southern hemispheres both contain lots of ice, but there's more ice in the north because there's more land. Land has a lower heat capacity than water, which means that water doesn't change temperature as easily as land does. This is why coastal regions are generally more mild and why ice forms more easily on land. Just look at the difference between the northern and southern hemispheres. In the south, there are ice caps that grow during its winter, but not nearly as much as they do in the north. During the winter, the land above the Arctic Circle is covered in darkness, experiencing twilight 24 hours a day. It's very cold, and lots of ice forms during the winter. And this is true no matter what's going on with Earth's orbit. The key variable here is how much ice melts during the summer. This depends on how much sunlight there is during the summer. Now, you might think that this doesn't change, but it does. Milankovitch showed that over hundreds of thousands of years, the amount of summer sunlight can shift plus or minus 15%. This can bring ice ages. This can end ice ages. How can the amount of summer sunlight be changing? Well, first, the distance from the Earth to the Sun is changing. And second, the Earth's tilt is changing. The Earth's axis is currently tilted at 23.5 degrees, but this changes. Other objects influence the Earth gravitationally, nudging its tilt up and down. Every 41,000 years, it cycles up and down. When the Earth is more tilted, there's more sunlight during the summer. More summer sunlight means that more of our ice melts away. With less ice on the ground, less light is reflected away, giving us a warmer climate. Earth is unusual in that its tilt doesn't change very much. Earth has a very large moon, which stabilizes its tilt. Mars has two tiny moons, and so its tilt changes much more dramatically. The next effect is the distance from the Earth to the Sun. The Earth's orbit is not a circle, it's an ellipse. Every 4th of July, we celebrate aphelion, the day that the Earth is furthest from the Sun. Then in January, the Earth moves closest to the Sun. Now the planets Jupiter and Saturn both nudge the Earth, causing its orbit to shift slightly, becoming either more oval or more circular. This happens over a period of 100,000 years. This effect is wildly exaggerated in this diagram. It actually looks more like this. You can barely even see that the distance to the Sun is changing, but this subtle change has important consequences for our climate. Earth as a whole receives 6% more sunlight during January than it does in July. The seasons change because the North Pole sometimes tilts towards the Sun and sometimes tilts away. The change in the distance to the Sun, this works against the change in the seasons. This moderates the seasons in the north, since the Earth is furthest away in July. But this was not always true. The Earth's axis is moving in a circle. It's spinning like a top. This is called precession. In fact, I made an entire video about this. And what this means is that 13,000 years ago, the tilt of the Earth was reversed. When the Earth was closest to the Sun, it was summer in the north. The distance change didn't oppose the seasons, it amplified seasons, making them more extreme. Now, warmer summer means more melting. More melting means less reflection, which means the climate as a whole is warmer. The amount of summer sunlight is affected by 3 long-term cycles. 1 changes the tilt. 1 makes our orbit more circular or more oval. And 1 changes how the distance to the Sun matches with the changing of the seasons. These 3 cycles powerfully impact our climate. Scientists have measured the history of our climate using ice cores. Now, Earth's climate is complicated. You can't just reduce it to a single input. But the Milankovitch cycles have played a key role in our climate for hundreds of thousands of years.